We want to calculate integral dx over square root of, say, 4 plus x squared. So the substitution we are doing here is trig substitution. X equals to 2 tangent theta, and dx comes to 2 secant squared theta d theta. Alright, so let's proceed with that substitution. We have 2 secant squared theta d theta over square root of 4 plus 2 tangent theta squared. So let's have a look at that expression under square root. So that equals to 4 plus 4 tangent squared theta. Factor 4 out, we have 1 plus tangent squared theta, so we have 2 secant 4 secant squared theta. So that goes inside of that square root. So we have integral of 2 secant squared theta d theta over square root of 4 secant squared theta. So let's try to figure out what that equals to. So 2 secant squared theta d theta over 2 absolute value of secant theta. Right? If you look at the expression, we want to have x to be 2 tangent theta. So if you recall that tangent is between negative pi over 2 and pi over 2, we'll go from negative infinity to plus infinity, and we want x to run from negative infinity to infinity. So theta is between negative pi over 2 to pi over 2 is good enough for us. But if theta is between negative pi over 2 and pi over 2, then secant theta will be positive. So absolute value of secant theta, absolute value of positive, will be just secant theta. So I'm going to rewrite this curl one more time. 2 secant squared theta d theta over 2 secant theta. Reduce 2's, reduce 1 power of secant, so we get integral of secant theta. You recall that the integral of secant theta is natural log of secant plus tangent. Do back substitution. So we recall that we are doing substitution x equals to 2 tangent theta. So let's have a look. I will write the intermediate steps. And I will write down our substitution here. So recall that x equals to 2 tangent theta, so tangent theta from here is x over 2. Right? Recall that if you look at the right triangle, tangent is opposite over adjacent. So missing hypotenuse is square root of x squared plus 4. So we have x squared plus 4. So this triangle, we already know what tangent is. Now we need to figure out what secant. So secant is 1 over cosine. Cosine is adjacent over hypotenuse. So if we do that, and 1 over, so we have to multiply by reciprocal of that expression. So we have square root of x squared plus 4 over 2 for secant. Now we'll substitute it back. So we're going to get natural log of secant as this, x squared plus 4 over 2, tangent is that. And that is essentially our answer. The only thing we want to do is rewrite that combined fractions. So we're going to get natural log of square root of x squared plus 4 plus x over 2 Then you recall property of log is natural log of quotient equals to difference of logs, and when you recall that natural log of 2 is a constant will go together with that c, so anyhow we're going to get natural log of square root x squared plus 4 plus x plus another constant c, where this constant c is slightly different from this one. To summarize, here we have integral, and inside of that integral we have expression which involves square root of a squared plus x squared. Then we want to do trig substitution. X equals to a tangent theta. Here we'll assume that a is positive. Then we do that substitution. We're going to use the fact that dx equals to a secant squared theta d theta. And also we're going to use that square root of a squared plus x squared. Something similar to what we did before in the previous example is going to give us a squared secant squared under square root, and because we assume that a is positive, and the same time we want the assumption on the theta, so we're going to get a secant theta.